I'm Sir Rifat, and once again with new syllabus mathematics, book 2, chapter number 1, direct and inverse proportion. Okay, now I start by considering our term proportionality. Both in physics, physical science, and maths, we define proportionality. Okay, so let's start from the word proportionality. Okay, proportionality is a relation between two physical quantities at a time. So it means we consider two physical quantities, one of them depend on other, then there must be a relation. So a relation between two physical quantities. Okay, so proportionality is a relation between two physical quantities at a time. Although there are so many formulae having more than two physical quantities, so by combining different relation, we can formate a relation having more than two physical quantities. But at a time we only consider two physical quantities. So simply a proportionality is a relation between two physical quantities, and there are two types of proportionality. One, direct proportionality, or the first relation is on direct proportional. So two quantities are direct proportional or inverse proportional. So I consider direct proportionality. Direct proportionality. Okay, now it is a relation between two physical quantities. It's okay. The word proportionality define a relation between two physical quantities. Now we have to define just direct. What is a direct proportionality? Okay, relation between two physical quantities in such a way, on increasing one physical quantity, other one will increase. On decreasing one physical quantity, other one will decrease, but with the same rate. If we do not consider the word with the same rate, this is called correlation. Positive correlation or negative correlation, right? But the word is direct proportionality. So a relation between two physical quantities, on increasing one, other one will increase with the same rate. Okay, so direct proportionality, relation between two quantities, on increasing one quantity, the other one will increase. On increasing one quantity, other will increase with the same rate. Other one will increase with the same rate, and on decreasing one quantity, other one will decrease with the same rate. So rather than writing on decreasing one quantity, just write down and vice versa, which means same process in opposite direction. Okay, on increasing one physical quantity, the other one will increase with the same rate, and vice versa. Meaning to say, on decreasing one physical quantity, other one will decrease with the same rate. Okay. So this is direct proportionality. Listen, when we talk about the two physical quantity, the one of them will depend on other. So there are two types of physical quantities. Whenever we consider a relation, one is dependent quantity, one is independent quantity. Suppose we consider volume and pressure. Okay, increasing pressure, volume will increase or decrease. Okay, decreasing pressure, volume will decrease or increase. It's okay. So it means there is a relation between volume and pressure. There is also a relation between volume and temperature as well. Okay, we consider two physical quantities, and suppose these two are x and y depends on x. So we consider two physical quantities, x and y depend on x. So we will work on it in the heading mathematical presentation for direct proportionality. Okay, this is mathematical presentation. Mathematical presentation. Okay, we consider two physical quantities x and y. Let x and y are two physical quantities. And y is directly proportional to x. Okay, so two physical quantities y and x and y. One of them depend on other. So according to the definition, on increasing one, other one will increase. On decreasing one, other one will decrease. So it means if y is directly proportional to x, okay, now y is directly proportional to x. How one can write this thing? Like this. Y is directly proportional to a x. So this is the sign of proportionality. For inverse and for direct, we use the same sign. Y directly proportional to x. Whenever we remove this one, there is a constant of proportionality. For example, y is equal to k times x. This k is the constant of proportionality, where k is constant of proportionality. This is constant of proportionality. K is the constant of proportionality. So it means on putting the value of k, if we are given, then y equal to k times x, it is a relation between y and x. And one thing remember, whatever quantity multiplied by the constant is a independent quantity. We always consider this quantity along x-axis. We always consider this quantity along y-axis. Always there are two quantities. Whatever multiplied by k, it is independent quantity. And whatever is over here, it is dependent quantity. Y depends on x. So x is independent quantity. It is independent quantity. Always consider along x-axis. Always consider along x-axis. Okay. This one is dependent quantity. Always consider along y-axis. Always consider along y-axis. Okay, so mathematically we should write y directly proportional to x, y is equal to kx, where k is the constant of proportionality. And whatever quantity multiplied by this k is independent quantity. So someone depend on it. It must be considered along x-axis, and this one is the dependent quantity. This one is the dependent quantity along y-axis. Okay, so it means in a relation there is one dependent, one independent quantity. Okay, now the next thing related to direct proportionality is the graphical presentation. This is mathematical presentation, and now we consider graphical presentation. Okay, we know to interpret data by picture. For example, pictogram, pie chart, bar graph, histogram, line graph. These are the presentation of data. So we are talking about the presentation of data, right? Now the next heading is graphical presentation. Now this is graphical presentation for direct proportionality. So two quantities which are direct proportional, how we will represent the data related to these two quantities. Always we have a straight line. So there are different types of line: straight line, curved line, circular line, parabolic, hyperbolic, elliptical. But we consider over here what? A straight line generating from origin. Will show graphical presentation of direct proportionality. So it means I consider over here, this is x-axis, this is y-axis. The x-axis is abscissa, the y-axis is ordinate. Okay, so we consider two axes like this, x, y. Okay, along x-axis we consider x, along y-axis we consider y, and in all cases you must draw a straight line from origin. Origin is a point where these two mutually perpendicular lines intersect. So this point is called origin. You have to draw like this, or we can draw like this as well. Any line, one of them. Both are straight lines and both generating from origin. So you draw any one line for all the relation between two quantities which are direct proportional. Always we draw a straight line, and we will consider different axes, different numbers over here, right? Different number will consider over here. But we have to draw a straight line, one of them, consider only one straight line. This will show direct proportionality, a relation between two physical quantities. This is independent physical quantity, this one is dependent physical quantity. Okay, now we consider some questions just to solve and to show you, okay, how easily we can solve a question related to direct proportional. Direct proportional. The question is, if x is directly proportional to y square equal to 32 when y is equal to 2. Okay, it's first part. So the question is, find an equation, meaning to say find a relation connecting x and y. So find an equation connecting x and y, find a relation between x and y. Okay, now read what we are given, what information we are given. x is directly proportional to y square. Okay, x is directly proportional to y square. And the very next step, x is equal to k times y square. And to find out the value of k, this is the final answer. But after putting the value of k, this will be the relation. After putting the value of k, and to find out the value of k, some information we are given. For example, listen, x is 32, x is 32, k times y square. We are given y equal to 2. So, square of 2. Now 2 square 4. Come over here. 32 upon 4 equal to k, or k is equal to 4 8s are 32. It means the final relation would be x equal to 8 y square. This is an equation connecting x and y, or this is the relation between x and y. Okay, part 2. Second, find the value of x when y is equal to the same. We can find out directly its value, no issue. If there is a question and with no part like this, find an equation connecting x and y. So, without making a relation, we are able to find out direct answer. Direct answer. Why? Listen, in direct proportionality, always there is a common ratio. Yeah, as I have written over here, k is equal to y upon x. Always, always it bears a constant ratio. So there is a direct proportionality, there is a constant ratio. If there is an inverse proportionality, they have the common product. Okay, we will talk about inverse proportionality after it. Okay, now listen. So a constant always equal to the ratio between dependent quantity to the independent quantity. So we are able to find out directly the answer. But over here, what happened? We have found out our relation. So you must use this relation right now. You must use it. So find the value of x. X equal to 8 times y square. Y 6. 6 square. Okay, 6 square 36, and 36 8s are 36 8s are. So it means double the amount 4 times 72, then 144, right? 4 times, and what? 36 multiplied by 8, 36 multiplied by 8 like this. 8 6 is 48, 8 6 is 24, and 280. So it means 36 to the 72 to the 144, and 144 double, what, 288. Or use calculator. Listen. So x would be equal to 288. So x equal to 288. Third part is draw the graph of x against y square. Okay. Now which one is dependent, which one is independent? Listen. Y square is independent. Consider it over here. Although this is x. No issue. This is y. Over here x. Right? X is dependent in this relation. Y square is independent. Okay, we always draw a line like this. This is the answer. Simply, this is the answer. We are going to find out the values. Okay, we can set them easily. For example, listen. For y is equal to 2 square 4. Right? Y equal to 2, meaning to say y square. So 4 will give you. Let's suppose this is 4 and draw this one like this. Make it over here 32. No issue. This is 32. This is 4. We are going to sketch, not plot the graph. We are right now, what we are doing? Sketched a relation. So we are making a sketch, not plot. Right? We are not plotting the graph. We are just sketching the graph. Okay. So this is 4, this is 32. And the other one, what we have in case of over here, y 6. 6 square 36. Okay, let's suppose over here there is 36. Suppose there is 36. Then what does it mean? It means like this. So what is this? This is at 36 the value of x to 88. This one would be 288. Like in the same way, you will work in the same way. You must work in the same way. We sketch. We are going to sketch the graph, not plot the graph. So, but always draw a straight line. Okay. Now we consider another question just to find out direct value without making this type of relation. Okay. Okay, this is question number 5. Z square is directly proportional to x cube. Okay. And z equal to 8 when x equal to 4. Find the value of z when x equal to 9. Find the value of z when x equal to 9. Okay, now listen. The relation between these two quantities, z square. Okay, first write down. Find the value of z when x equal to 9. Yes. Now this is the question. This is the question. Okay. Now listen. What is the relation? Z square directly proportional to x cube. Z square directly proportional to x cube. This is the first step. And this time we are not going to make a relation. Just to find out the direct answer of z. What is the value of z when x equal to 9? Okay. Now the relation is z square directly proportional to x cube. Okay. Z square directly proportional to x cube. What is the value of z? 8. And the square of 8 is 64. Okay. Now over here, x cube. X is 4. Now the cube of 4. So square of 8, 64. Cube of 4, 4 for the 16, for the 64. Okay, both give the same value. Okay, no issue. 8 square directly proportional to 4 cube. Now in the next step now. Find the value of z. Just write down z square over here. And when x equal to 9, so write down 9 cube over here like this. So according to first statement, the value of z is 8 when the value of x is 4. Okay. On the next step, find the value of z when x equal to 9. But original relation in between z square and x cube. We must place square over here, cube over here. And now listen, the relation is direct. The relation is direct. And in direct relation, there is a constant ratio. There is a constant ratio. So for the formation of ratio, multiply them in a cross. Multiply them by cross multiplication. If there is inverse relation, we multiply them by straight line, as inverse have common product, but the direct relation have common ratio. So ratio meaning to say we will multiply by means of cross product like this. Okay, now listen. Z square times 4 cube. So z square times 4 cube is equal to 8 square times 9 cube. 8 square times 9 cube. Okay. Now listen. What does it mean? 4 cube, 4 for the 64, the 64. 8 square 64. Both cancel out. Equal quantities on opposite side cancel out. But we are writing over here z square is equal to 8 square times 9 cube divided by 4 cube. Okay, this one cancel out by 4 cube. So write down like this. This one cancel out by this one. Yeah. So just we have 9 cube. Okay. Whatever we have 9 cube, 9 into 9 into 9. But we can resolve 9 into 3 square. 3 square cancel out by this square. So we have 3 and 3 cube 27. So the answer would be 27. You can use calculator. Otherwise, I'm making some calculation over here. Listen. Z is equal to plus minus within square root. What we have? 9 cube. Right? And one can write down like this. 9 cube meaning to say 3 square whole cube. This is 3 square whole cube, or use calculator. Okay, so z is equal to plus minus 3 cube, 3 cube. 9 is 3 square. One can write down like this: 3 square times cube, and this radical sign cancel out by square. This radical sign cancel out by this square. So we have just 3 cube, or use calculator. Now 3 3 9 3 27. So the final answer what would be the final answer? So z is equal to plus minus 27, or you can write down only 27. This will be the answer. So without making any relation, we are able to solve this one like this. So listen, calculation make a question difficult or easy. So it based on calculation now. Simply the concept is very easy, right? Whatever we have information, right? After theory, all the questions related to this one are easy. So next time we'll try to solve some more questions, but in the next class I will consider inverse proportionality. Make definition. After making definition, then mathematical presentation, and then graphical presentation, and then I will solve 2 or 3 questions. Right? I hope you will like it. So theory makes a bit perfect. Right? Always continue with the theory. Listen, the calculation, okay, depend it very person to person. So you can use calculator over here or some other resource, you can use it. Okay, but the theory always reduce the number of steps. So it makes you perfect. Okay, thank you. If you like this video, so please subscribe for further videos, comments, share, and press the bell icon. Thank you. Allah Hafiz.